Hey everyone, and welcome to this explainer. I am absolutely thrilled to dive into today's topic with you. We're going to tackle a transformation that honestly feels like literal magic for IT support teams. We are going to take those vague, frustratingly unhelpful customer complaints and turn them into highly actionable, precise engineering data. And we're going to do it using the Google Chrome DevTools Performance tab. So if you've ever felt completely stuck trying to prove to a developer exactly why a user is complaining about a slow page, well, this explainer is going to give you a superpower. Okay, let's just jump right in. The checkout page is just spinning. Fix it. Oh man, we have all seen this ticket, right? It's that classic, dread-inducing support note that always seems to land in your queue at like 4:30 p.m. on a Friday. The customer is angry, revenue is potentially blocked, and yet you have absolutely zero technical context to go on. I mean, what does spinning actually mean? Is it their network? Is it our server? Did a JavaScript file just lock up entirely? Passing this vague ticket directly to an engineering team is pretty much a guaranteed way to get it bounced right back to you with that dreaded cannot reproduce label. And this right here perfectly illustrates the difference between the old way of doing things and the new way. Over on the left, you've got your vague support note. Checkout is slow. It completely relies on guesswork. But look at the right. This is the ideal escalation note. Trace attached, 600 millisecond render blocking JS file identified on click. That is the absolute gold standard. Today, we're going to learn how to become what I like to call a map reader. By reading the browser's execution map, you transition from just passing along complaints to actively diagnosing the exact point of friction. So here is our diagnostic map for today. First, beyond vague support tickets. 2, recording your first trace. 3, reading the flame chart. 4, finding blockers and long tasks. And 5, escalating the checkout slowdown. All right, let's kick things off with Section 1, Beyond Vague Support Tickets. You might be wondering, why is the page slow simply not enough information anymore? Well, because that vague complaint hides a massive, massive business problem. According to 2026 browser performance data, failing to meet your largest contentful paint targets, which is basically just how fast the main content of a page loads, can slash conversion rates by up to 30%. 30%. Think about that for a second. If your checkout page is stalling, you aren't just annoying a user, you are actively losing up to a third of your sales. As an IT support engineer, you've got to view every single millisecond of blocking time as an absolutely critical business friction point. Moving right along to Section 2, recording your first trace. So to find those lost milliseconds, we need to capture some clean data. This is the absolutely crucial first step in our map-making expedition. First things first, always open an incognito window. This is super important because rogue browser extensions can secretly chew up CPU and completely ruin your trace. Next, open up Chrome DevTools and navigate over to the Performance tab. Hit that little circle icon to start recording, and then, and this is key, perform the exact action the user complained about. Like actually click that Pay Now button on the demo page. Finally, just hit stop. Which brings us to Section 3, reading the flame chart. Okay, so you hit stop, and bam, you're hit with this overwhelming wall of data. Take a breath, don't panic. It's really just a topographic map of the browser's engine room, and it is perfectly color-coded to help you out. Blue represents loading, so that's fetching and parsing your HTML. Yellow is scripting, that's your JavaScript execution, and honestly, usually our biggest culprit for slow pages. Green is rendering, which is the browser calculating layouts, and purple is painting those actual pixels onto the screen. Seeing massive blocks of these colors shows you exactly where the browser is struggling the most. Now, to actually read the flame chart in the main track, you just need to keep two simple visual rules in mind. The x-axis, running left to right, represents time. So, pretty simply, wide blocks are bad. A wide block means an event took a really long time to finish. The y-axis, running top to bottom, represents the call stack. When you see blocks stacked vertically on top of each other, it means the upper events actually cause the lower events to happen. You are literally looking at a visual hierarchy of exactly what the browser was told to do and exactly how long it took to do it. All right, let's get into Section 4, finding blockers and long tasks. Now that we know the terrain, it's time to go hunting for our very first major bottleneck, anything crossing the 50 millisecond threshold. In the flame chart, if a JavaScript task takes longer than 50 milliseconds, it gets flagged as a long task. DevTools actually calls this out for you with a little red triangle and these red diagonal stripes over the extended portion. These long tasks are terrible because they freeze the main thread, which leaves your user clicking buttons on the page that do absolutely nothing. Then we have our second major culprit, the render blocking resource. These are typically heavy CSS files or synchronous JavaScript files sitting up in the head of the document. The browser literally has to stop rendering the page entirely just to download and execute them. If you look up at the network track, right above the flame chart, Chrome explicitly marks these render blocking requests with a red triangle marker in the waterfall view. Spotting these is so important because moving them out of the critical path is often the single fastest way to speed up a page load. And finally, Section 5, Escalating the Checkout Slowdown. Let's actually apply all of this to a real-world scenario. Minute 0, you get a ticket saying, when I click Complete Purchase on the checkout page, it takes 8 seconds to load. Minute 2, you pop open an incognito window, hit record, click the button, and capture a clean trace. Minute 4, boom, right there in the main track, you spot a massive 6-second wide yellow block with a red triangle. It's a long task, triggered by a third-party payment script. Minute 6, you right-click, annotate the trace, and label it Payments API Locking Main Thread. By minute 8, you've escalated the exact data to the devs. You just turned an impossible mystery into a highly precise diagnosis in under 10 minutes. How cool is that? So, to ensure your engineering team absolutely loves you, always use this quick escalation checklist. First, include the exact reproducible steps. Second, name the specific culprit you found. Is it a long task, a render blocking script, or maybe a forced layout reflow? Finally, and this is the most important part, attach the annotated .json trace file. When a developer opens that file, they see exactly what you saw. You've just drastically reduced their time to fix, and for sure, you've ensured your ticket will not get bounced back with that annoying cannot reproduce label. So as we wrap up this explainer, I really want to leave you with this thought. If you can decode the browser's execution map using Chrome DevTools, what other invisible friction points can you eliminate for your users? Think about it. You are no longer just fielding complaints. You are an essential, proactive part of the business's overall performance strategy. You now have the tools to uncover exactly why the digital experience is failing and the exact vocabulary to help fix it. Thank you so much for joining me on this explainer. Keep practicing, keep recording those traces, and I'll catch you on the next one.